how to introduce this topic. And I remembered his second year checkup. I wasn't there, my wife was. She gave me the report later. It was like 10 o'clock in the morning, like now, and I was in class. And she gave me the report. Oh, not that. Lights over here. He just turned 7. That's better. He just turned 7. But this checkup is the one that goes down in my mind as the statistics lesson. This one he went to this second year checkup. And some of you guys are parents or have taken kids to checkups before, and some of this stuff is going to sound familiar to you. So these are what he came back with that day. He was in the 80th percentile for weight, the 90th for length, and my favorite, which they've now stopped measuring, which breaks my heart, 85th percentile for head girth. I wish they stopped.
I've got a 9-month-old, they don't stop. Maybe it's just...
Oh, I know, since 2. I think it was 5 was his last checkup where they measured that, and they've stopped since then. 9-month-old. So you're familiar with this? Very nice, Tom. Very nice, good, yes. So I want to talk about this today. And you might know the answers to this already, which is great. So answer Max's question. He's in the 80th percentile for weight. He was. Not anymore, he's not. 80th percentile for weight, 90th for length, and 85th for head girth. Head girth. That's mostly hair, by the way. So, I don't know where he gets it from. So, explain. Let's go with his weight. Andrea, please. Andrea, not Andrea. Andrea. There we go.
What my good doctor told me is that it meant if we put him in a room with 100 other kids, they would weigh as much as 80 or not weigh as much as 80.
I love your doctor. I love your doctor. That's the first. Excellent. Good. Say it again a little bit louder if you don't mind, Andrea.
If they were in a room with 100 other kids, they would weigh it the same as 80 of them.
So if you would, and we did not talk about this before class, FYI, but there's 100 randomly selected white American 2-year-old males. Okay, find Max. Where's Max? Wow. I'm doing what your doctor told me to do. I love this. You have no idea how happy I am right now to hear him. The fact that he explained that to you in that way, mwah. Where's Max? What do you think? 29. Anybody else?
28.
28. 25? No, not 25. How come not 25? You guys 29, 28, yes, 25, no.
Well, because you're going out from 30. 30.
Oh, good. So you guys are doing this. You guys are not hyper-focusing on one little cell. You're kind of looking at where they all fall.
Yeah.
Good. Does it bother you that there's a bunch of 25s? Ah, that's good. Touche. Bunch of 27s as well. So this might be a little bit easier to look at.
Yeah.
Yes, this is why we learn things like histograms, is to take data that's messy, imagine 100 kids, 100 2-year-olds in one room. Holy crap, speaking of messy. But here's what they would look like if you had them all stand. Actually, the vision I'm getting right now is this is looking down at the top of the room. Put 100 kids in a room and have them line up shortest to tallest and have them stand front to back as like a histogram. What how long that would take to get a bunch of 2-year-olds?
That would be height, though, not weight.
No, you can stack them by weight, though. You can measure their weights and then have them stand. 25 pounders, 26 pounders. You could do it by height. It would be visually appealing to do it that way. Yeah, that'd be cool. I used to try to do that in 243, but people got tired of walking outside in the winter. But nonetheless, it's a very nice live histogram. It's pretty cool. It's fun to do that with. So, here we go. Where's Max? Where's Max? So we had votes for 28, 29. That was, or 27, 28. Is that correct? 28, 29. 28? Cool? Cool. Okay, maybe it's, yeah, good. Any other votes? Go ahead. 31? 31? Okay, 31. Good. 31 down towards that way. Good. Now, I want to load this with a couple, well, first of all, forget Max for a second and describe this data to me. If you had to pick a word or two to describe the shape of that data, please, Sandra.
Bell-shaped.
Call it bell-shaped. Who says bell-shaped? Who says skewed? Okay, a couple votes for skewed, lots of votes for bell-shaped. Who says somewhere between bell-shaped and skewed? That's probably a pretty good place to live too, right? Just FYI, every data set is skewed. Every data set is skewed if it's not perfectly mathematically symmetrical. That does not mean it's not bell-shaped enough to use the average from. So when I ask if something is skewed, in your opinion, is it gotten too far away from bell-shaped to be considered bell-shaped? Does that make sense? You're not going to be right or wrong because there's no gospel according to skew that says if it gets past this shape, it's now too skewed. Eric, go, please.
Well, what would the definition of the same be?
The same as a bell curve?
Well, no. If you you were in a room with 100 kids, you'd be the same as 80 of them. I don't see 80 kids who are the same.
Oh, no, I don't think that's what Andrea said. I don't think. Say that again, what you said? I don't think. Go ahead.
Well, yeah, at the 80th percentile, so the average would be at the 50th percentile.
Okay, assuming something. We'll come back to that. Love that, by the way. Go ahead.
So he would weigh more than 80 of them.
See, it's not equality, it's inequality.
Let's weigh more than 80 of them.
That's.
I heard he would be the same as 80 of them.
Don't you worry. That would be that would be very low variation in the sample, right?
Yeah.
I mean, if you think about it, it's 80% identical and 20% deviant. You got a curve that looks like this.
I was like, that's...
No, good for you for catching on that. But here, so let me paint the picture then. Oh, sorry. Take a look at this curve, if you guys would. And please tell me what percent or how many, because it'll be what percent or there's 100 of them. So if you tell me how many, you've told me what percent. Weigh less than 26 pounds. Less than 26 pounds, friends. Here's 26. So less than that, less than that. I think I have an answer.
22.
I got 20. I have 22, 21, and 20. I'm going to count again. So I got 8 here.
Yeah.
4 more is 12.
Right.
14, 16, 17, 20. Is that fair?
Yeah.
So 20 of them are less than 26. That means the other 80 are 26 and more. Is that fair? Okay. So 20% are under 26 pounds. Is that fair? Good enough, good enough, good enough. Just counting in. This is why I gave you those primer quizzes. How many numbers in this list are below blah, blah, blah. Get you ready for this. Cool, good. All right, let's do the same thing again, but now with 29 pounders. I think I have an answer. I'm afraid to say it though. You guys had it better than I do. Good, that's what I got, Teresa. 49?
49.
All I did was I knew this was 20, plus 9 is 29, plus 7 is 36, plus 13 is 49. So 49, let's call that half. That's just about half, right? Half of the kids are less than 29 pounds, and half of the kids are 29 or over. So what did we just find?
The average.
Maybe, but we definitely found the what?
Median.
There we go. See the difference? We definitely found the median. We may have found the average too, if the data are symmetric enough. Somebody just said it, symmetric enough. If you've got roughly balanced, that's the problem with skew, remember? That's the problem with skew. As data gets more and more skewed, the median stays right where it is, and the damn average starts chasing the tail of the distribution. So as you get more and more skewed, your average is going to start heading this way. This is not exceptionally skewed, but it's skewed. So the average is going to head south where the median stays over here. Does that make sense? Think of it as the cookie tray. Cookie tray, right? Where would you put your hand to balance this tray of cookies? Where would you put your hand?
Further. Yeah.
Somewhere in here?
Yep.
Love it. Love it. Very good, very good, very good. But we just discovered that this was the median.
Yeah.
Which makes sense. Your average is a smidge left of that, as it should be. Now imagine what would happen if this 20-pound dude here, one of these 3, was actually 10 pounds. First of all, you have to feed him more. But secondly, where would that do to your balance of your hand? We'd have to do this. It's Kevin's example. It's your university example again. Thank you, sir, for bringing that up. So glad somebody's reading that. Cool? Okay, last but not least, do the same thing for 31-pounders. What percent or how many, whatever you want, are less than 31 pounds in this sample? Granted, it's just a sample. I think I got it. What do you guys say? 80? 80? Yeah? So that means that we've got 20% of the data from 31 to 33. And what's totally bitchin' is we also have 20% of the data from 25 down to 20. That's the same percent, the same number of kids are in both of those tails, aren't they? But the two tails are very differently shaped. This one's long and skinny, that one's short and tall, or skinny and tall. All right, so That means if 20% are 31 or above, that means 80% are below. So my question is, how heavy is Max? He must weigh 31 pounds, because that means he's heavier than 80% of the kids in the population. Granted, this was a sample, but I drew the sample based on the population sizes. I'll show you in a second. So your doctor makes me so happy, because he explained to you exactly what a percentile rank is correctly. You're the first person, I've been teaching this for 20 plus years, first person I've heard that's got it explained to them correctly. I've heard so many wrong explanations of what percentile rank is, but that's exactly the right one. Your doctor, high five him next time you see him. He's so happy. So here's a general definition of percentile rank. It's simply a number. And it's a number that tells you what percent of the population you exceed in whatever you're measuring. In whatever you're measuring. If you're in the 98th percentile for height, you're pretty damn tall for your population. Whatever your population is. It might be males, it might be females, it might be American males from age 45 to 50, whatever you're measuring. But if you're in the 98th percentile, you're pretty damn tall. If you're in the 50th percentile for an IQ measurement, you are good. You're average or you're median, right? You're right in the middle.
Right in the middle.
Half of the population has a lower IQ than you, and half of the population has an higher IQ than you. Is that fair? Right? When I first moved here, my first dentist, not Dr. Tim, my first dentist told me, man, your gums are like in the highest percentile I've ever seen. Which I thought was so funny, because on the East Coast, I had the worst gums my dentist had ever seen. And I said, what does that say about bending people's mouths? I shifted from the worst to the best just by moving 3,000 miles. Something magic happened across the Mississippi, I don't know. But that was interesting that she used it in the correct way. She used that phrase in the correct way, highest percentile. Mine were better than whatever percent that she was talking about. But that's all percentile. Sandra, go.
I heard that a lot of people drink a lot of soda on the East Coast.
Source, please. Source, please. Jay's like, I'm your damn source. Go ahead.
It's not a source, but it's an observation.
Observation.
In New York, you can outlaw certain amounts of soda.
That would not surprise me,
Yeah,
actually.
because
Yes,
they were
they did.
consuming so
The big
much.
bulbs.
They were consuming so much.
That would not surprise me whatsoever.
It's just we live a healthier lifestyle on the West Coast.
It wasn't the consumption.
Source, please.
The fact that there's
No, I loved it. Linda, go ahead, please.
You
it's
did
not
it.
the consumption, it's the fact that there's so much obesity. It's a sugar tax, and they're trying to make it pass not just in New York for the amount of the, like those 32-ounce go get a Coke at 7-Eleven thing.
That used to keep me alive on tour, just so you know. When we used to
Yeah.
drive across the
Yeah.
desert back in the 90s when gas was 80 cents a gallon and we had to drive from like Denver to San Fran to play a show, I would stop at those brand new gas stations, get the 64-ounce Mountain Dew, plop it between my legs with the straw, I'm like, let's go.
Yeah.
13 hours later, I hadn't blinked, I hadn't peed, and we were in San Fran. No, I'm with you. It totally, totally. I don't want to go anecdotal versus statistical. But who knows why, right? I mean, I've heard other arguments that the water's not fluoridated here, but that wouldn't have anything to do with gum health.
No.
That would have to do with tooth, I would imagine, enamel health, maybe. Please, Eric.
Yeah, well, if we lived healthier lifestyles here, wouldn't our
It's a
gums
fist
be
fight.
healthier?
That's what he said.
I sense a fist fight breaking out. No, the problem was, apparently, I was on the low end of gum health on the East Coast, but moving here, it was... I don't think there's a correlation, and I don't want to get in a fist fight, but healthy lifestyle might not imply healthy gums. It might not. I've never done research on it. I see where you're getting at, Eric. I totally see where you're getting at, Sandra. But I don't, and the problem is we could all be saying the same thing, coming to different conclusions, because we're looking at slightly different aspects of the data. When I say gum health, what am I talking about? Am I talking about surface area covered by the gums? Or am I talking about the pinkness of the gum versus the redness versus the inflammation? I mean... Am I talking about the average rating of 1 to 5? Is 5 worse or is 5 good? I forget. I always forget that. Is 1 good, 5 bad? I don't remember. 5, okay, good. I kind of got it.
Bad.
Okay. So Eric, I don't have an answer for you.
But if we were talking about soda specifically, then that would mean that soda cleans your gums. If the East Coast drinks more soda.
And the trick with that one is, the trick with that, right.
That's just correlation.
Exactly. That's my exact point is just because, I mean, I drink the hell out of coffee. Right? Probably to the point where it's not exact. I just read a study relatively recently. I shared it in 244 today. Drinking more than 28 cups of coffee increases your risk of early death. I'm like, 28 cups of coffee? Who drinks Wait, I drink that. That's 4 cups a day. 28 cups of coffee per week is 4 cups a day, and a cup is 8 ounces.
Yeah.
That's not that much coffee, honestly. Right? I was like, oh boy. But it's correlation causation, right? What else do I do that burns off that stuff that flushes my liver, that does all kinds of wonderful stuff? I mean, it's tricky and it's loaded. How do we get to talking about that? Gums, percentile, the dentist. I shouldn't even have said anything. Wow. That was an awesome derailment, though. Thank you all. Got some life in there. It's good. It's good. Woo! Developing the vocabulary. Okay. So we found Max. Here he is. Now, if you would, suppose your kid is 27 pounds. What percentile is that kid? What percentile is that kid if he's 27 pounds? What percent of the data is he heavier than? I'm going to count it here.
20% was.
So we got 9. We didn't do this one already, did we? We did 26, didn't we?
26.
So I'm doing 27 now. Oh, so actually we know the answer. It's 29. It's got to be 29 because you knew that these kids were the 20th percentile because they were bigger than 20%. So these kids have to be the 29th because they're also bigger than these 9. 20 plus 9, 29. Is that fair?
Yeah.
Is that a fair? Okay. So the 27 pounders are the 29th percentile. The 28 pounders would be 29 plus an additional 7 more, 36. So these guys are the 36th percentile. Is that fair?
Yeah.
So in order to get any successive number, you have to add in all those below. Is that believable? So who's this kid over here? How would you describe the 33 pounder?
100%.
It's easy to call him the 100th percentile. But technically speaking, is he?
No.
Because he can't exceed himself, right?
Exactly.
So, although if you say 100th percentile, I know what you mean. You mean the heaviest item in the population. Andrea, go. Andrea, go. Go, I'm sorry.
Because my 12-year-old for height, she said that he was off the 100%.
Can we come back to that? I knew that was going to come up at some point. Same doctor?
Yeah.
I feel differently about him now. That's okay. We'll come back to him. We'll come back to him. We can give him a high five and then a finger wag too. Well, can we come back to that? Give me a moment or two. Because, yeah, anyway, we'll come back. Linda, go ahead.
Sorry, how about the negative percentiles? Because I've had that too.
Can we come? I think we addressed both of those, I think, in the same argument, and I'd say argument, discussion. About 10 minutes, I promise to come back to that because that's something I always hear about, and mathematically you can't be either. But I'll come back to why. Fair, thank you. So this kid, mathematically, would be the 99th percentile, wouldn't he?
Yes.
Because he's bigger than 99% of that group. He's not bigger than himself. He's bigger than 99% of his group. Some statisticians will say he's the 99.5 percentile because what they do is this cool little calculation where they take all those below plus half of those that are equal to you and then make that a percentage. So they would take the 99 that are below plus there's 1, him, take half of that, that's a half, 99.5. Now, I personally like just going with the strictly less than. But do you see a problem with that? And it's tied similarly to what Linda was just talking about. What if your kid's 20 pounds? What percentile is he? By the mathematics of what we just talked about, he's the 0th percentile because he doesn't exceed anybody. Correct? And conversationally, if you say somebody is the 0th percentile, that just means they're the smallest, or the lightest, or the shortest, whatever ist you're measuring. And if you say 100th percentile, that means they're the biggest, or the heaviest, or the off the chartists, but the top of the chartists. Is that fair? Mathematically, though, you can't be in the 100th or the 0th percentile.
Right.
So
You have to have a place.
it has to have a place, and that's why some statisticians do the half trick. They'll say there's nobody below this kid, but there are 3 that are the same as him, so cut the 3.5 and call it 1.5, and say he's the 1.5 percentile.
Oh.
That's how statisticians get around from the 0th percentile. What I'm telling you is, just like the mean, just like the standard deviation, just like all those measures we've talked about so far, these are human-made formulas. Therefore, they're not law. It's not like gravity. You drop something, it hits the ground because there's a massive attraction between a large body like the Earth and a small body like your water bottle or your keys if you drop it in the toilet. Damn it. These are man-made, woman-made, people-made formulas. So they're open to some interpretation. I like to think of them like this. I think this is the clearest way of thinking about it. Just what percent are you bigger than? Because, I mean, honestly, what are the chances you're going to have that kid at the very bottom of the scale or that kid at the very top of the scale? Now, every class, I hear about a negative percentile or over 100th percentile, off the chart percentile. I want to talk about that momentarily, but not quite yet. I did want to, oh, please Tom, go.
Does your top and bottom conversation change at all if it's discrete versus continuous data?
And technically speaking, this is continuous data, isn't it? Technically speaking, it's weights. So they really aren't 28, 27. Max came in at something between probably 30 and 32 pounds. They called it 31 to round it off. So theoretically speaking, nobody is exactly the same weight as Max. Does that make sense?
If you're counting it discretely, I mean.
If you're counting it discretely, you're pretending it's discrete. It's still continuous. So yes, your answer, I love your question. And the answer is yes, it does change because there are no longer a finite number of jumps. I can't do this with continuous data. There's no such thing as jumping from 20 to 21. There are infinity of numbers between 20 and 21. 20,
Say
20.
I didn't say it wasn't weight, I would say it's kids wearing green shirts, blue shirts, yellow shirts.
Oh, gotcha. That's purely discrete. Of course, that's purely discrete, right? Number of kids, number of kids, number of kids. So yes, it does, but it changes in a way that can be metriced on whatever curves equation you have. You can deal with it. We will deal with it in this class as we get. I want to move towards more continuous stuff later on in the course. I like to keep it discrete at first because we get the ideas discretely, and then once you got the ideas locked down, we can slap in the equations and deal with that in turn. Great question. No, it's a fantastic question. Completely spot on. Yeah, good. And I'm pretending this is discrete by skipping all the halves and whatnots. Cool? Good question. Good question. I want to share something with you. This might look like a headache. Does anybody recognize what you're looking at right here? Besides, it looks kind of cool. A wave. Is there any difference between this data and this data? Ooh, ooh, ooh.
It's area under the
Ooh, yes, it's an integral. Very nice. I wasn't thinking that. They're very, very good though, John. Yes, it's put in order, John. So look, 20 pounds, right? Still weights in pounds. 20. How many 20-pound kids were there? Do you remember? I think
Three.
Three, right? So if you look at that bar, that's about 3 high. Notice the scales change on this axis. How many 21-pound kids were there? There's only 1. Why is this bar now 4? Because it's the kids at or below that weight. So remember all that kind of adding we had to just do to figure out the percentiles of 26 and 27 and 28 and so forth and so on and so forth. This does it for you. So this is why when you get the 33 out there on the end, 33 on the end goes up to 100. Because every kid in that sample was 33 pounds
Or less.
or less. This becomes a much easier tool to use if you have to find percentiles.
And the 80 is just like right there.
Exactly. Tom, go. Yes, exactly, Sandra. Exactly. It pops immediately to you. Go ahead, Tom.
Well, if you put the 33 kid all the way up to 100, then why did you put 20 to 0?
I'm just saying, I'm not confusing the actual data itself with the formula of percentile that I've chosen to use that one arbitrary formula. Is that fair? Yeah, this is pure data. That's why I like it. It speaks for itself. It doesn't need to be interpreted anyway. And I like this form too because if you've been to the doctor, you've seen, this is just another look at it, just spread out as, it's called an ogive, which is one of these great, everything is labeled, it's a scatter plot, it's a frequency polygon, it's a histogram, it's an ogive, it's such a great word, ogive. It's got some fun history, it has to do with Gothic cathedrals actually, weird. But this is what they hand you, and they were seeing some nods, have you seen nods around the room? Yeah, seen one of those before. They're showing you ogives. They show you ogives, and the ogives have, this is super fun. If you've never seen one of these before, it's very, very interesting. This is what actually came home. I knew what Max weighed when that paper came home because, I'll show you. We know he was 24 months, okay? Now, I knew he was 31 pounds because if you go to weight, pounds, 31, and you come across and you see where that meets 24 months, there was a dot placed right there by the doctor or the nurse or whoever did this with my wife. And when you put the dot right there, I just go to that dot and go, okay, so I lost my place already. Here we go. Right, no, up here. Well, if you look at this line, this would be the 75th percentile line. This is the 90th percentile line, and Max was right here. So they said, hey, he's about the 80th percentile. No problem. So, but Jim was upset. I said, what are you so upset about? And she's like, well, it was the conversation I had with the nurse. I said, well, what was the conversation? And they said, apparently the nurse said, your son's in the 80th percentile for weight. And Jen's like, yes. And he's running around the office, you know, being a 2-year-old, you know, running around, getting in everything. Syringes. And And the nurse goes, what are you feeding him? And Jen's like, food. Her exact words, if I remember correctly. And the nurse was like, what kind of food? And Jen said, why do you ask? And apparently, at this point in time, there was a guideline at the doctor's office that said, any child, we're seeing some nods, any child that came in over the 50th percentile, the parents were asked, what are you feeding? And then Jen asked again, why would you pick the 50th percentile? We're trying to head off childhood obesity. And without missing a beat, my wife, love you babe, she goes, do you also ask all the parents whose kids are in the below 50th percentile and you're worried about undernourishment? The nurse goes, yes. And then my wife, without missing a third beat, goes, that means you're warning every single parent, about either over or under feeding their child. Because unless you land exactly at average, right, exactly at median, Blake, your face is what my face was too. But then my wife asked all the questions I would have said too. And the nurse backtracked and said, we're just trying to, and Jen was like, I know what you're trying to do. You're trying to be careful. You're trying to get out in front of people. We now know so much is set in place in the first 3 years of a child's life. Mental, physical, emotional. So much of that is set in place in those first 3 years. I just read another number popped out. 85% of your child's mental development happens in the first 3 years of life. That is crazy to think about. I haven't sourced it, but that is crazy to think about. So much in such a small period of time, you know, right? It's worth all the sleep you don't get. It totally is. If the sleep you're not getting is because you're reading and you're talking and you're singing and you're laughing and you're keeping them out of the trash and eating cat turds. But so much of that happens in the first 3 years of life. That didn't actually happen or anything. So the nurse, I give the nurse a pass on that one. I give the nurse a pass on that one because we're looking out for the well-being. But it's also a misuse of a very simple mathematics. Did your doctor ever tell you that? Probably not, because I never heard it again after that 2-year checkup. Not the third, not the fourth, not the fifth, not the sixth. Because it's silly. It's silly to assume that just because you're over a certain percentile in one measurement. I said, Jen, did you ask her to look at his height? His 90th percentile for height. He's 85th for head girth. Maybe he's just a tall kid. And he was, but he's reverting back to the 50th percentile now. He's kind of grown, the rest of them are catching up to him. The other thing you have to watch too is, look how tight these percentiles are early on. Very, very tight. When they drop a pencil point on there and this is blown up to much bigger than it actually is. Some piece of paper they hand you. A dot itself can pick up 5 or 10% early on. People get so hung up on one measure. I'm reminded of the BMI debacle, you know. Talk about BMI. I'm borderline overweight by BMI measures. Borderline overweight. Because BMI ignores so many other variables besides height and weight. And then when you take even one of those variables away and only look at weight, what possible, yeah? Yes. So anyway, Jen took care of it. She's awesome. Let's take care of a break. And then we're going to come back, 105th percentile, negative percentile. We'll talk about that before we get back into this, yes.